Hello.
E aí, pessoal, tudo bem? Bom, eu vou começar falando em português aqui, mas já já a gente muda para inglês. Mas, bom, hoje a gente tem dois convidados muito especiais aí, o Aritra e o Ritwik. Eles são GDEs lá da Índia, né? Então eles trabalham bastante no mundo dali das imagens, na parte de visão computacional. E a gente vai ter o prazer hoje de receber eles para eles mostrarem para a gente o último projeto que eles desenvolveram, que é um projeto basicamente onde você descreve o que você quer mudar e você consegue fazer todo o resto usando vários modelos open source para modificar uma imagem, apenas passando o que você quer modificar. Vini, quer falar alguma
Legal,
coisa?
Pedro. Bom dia, bom dia. Primeiro, obrigado, Pedro, por organizar esse meetup com o Arita e o Ritwik são caras fantásticos, referência aqui como GDE no mundo. E eu acho que o recado é, nós como user group aqui do Brasil, de São Paulo, a gente tenta criar vários conteúdos em português, que é importante para a comunidade, mas também esse contato com o que está sendo desenvolvido fora é também super importante, né? Para aproximar, entender globalmente o que está sendo construído e tentar trazer isso para o Brasil. Então, obrigado de verdade, Pedro, por ter organizado. E acho que vai ser muito legal para o pessoal aqui conhecer. Não fiquem tímidos ou tímidas, qualquer dúvida, mandem em português, o Pedro vai estar aqui no background apoiando, pode traduzir, e mesmo depois quem for assistir a gravação, nos procure aqui do User Group, que vai ser bem legal, e evoluindo esse assunto aqui. Então, obrigado mais uma vez.
E agora vamos mudar para o inglês. So, hello guys, thank you for accepting. Yeah, like I think everyone will enjoy this presentation. The project is so cool. I had the opportunity to try. So just present a bit like Ritwik and Aritra. They are both ML GDEs from India. Like I think most of the ML GDEs in the world are based on India, and they are like special guys. They are very, very, very know like they know a lot about computer vision. So I'll let them present themselves. And if you have any questions, just like write in the comments, and they will answer. And that's it.
Cool. So, hello, folks. Thank you for joining and thank you for hosting us, Pedro and Vinny. I am Aritra. I am a machine learning engineer from PyMedSearch. Most of my days go into reading a lot of research papers, breaking them down into digestible blog post formats, and presenting out to you. I am also a Google developer expert in machine learning. I also work as a contractor for the Google Keras team. So that's who I am. Ritwik, over to you.
Yeah, so I am basically the same. I am also a machine learning engineer at PyMedSearch. If you haven't figured this out yet, we both love images and we both love vision stuff. So we try to work around that. And I'm also an MLGD and based out of the same city of Kolkata. So, and I also want to thank Pedro and Vinny and the wonderful folks at Sao Paulo for accepting us as speakers. And yeah, we had a lot of fun doing this project. We had a lot of fun discussing it with Pedro, so we can't wait to share what we have done and what is in store with the community here.
Cool. So, guys, the stage is yours. I will add your presentation here. And yeah, let me know if you need anything. I will be in the background.
Sure. So, yeah, basically, the way what the subtext reads here is text-based image editing with open source tools, and that's what we are looking to solve here. And let's first try to understand like why we chose this project. So editing of images or editing in general is hard. And the reason it's hard is because a lot of times you have to really focus on both the input which comes from the user and also iteratively tune that input so that the machine understands what you're looking for, because even with intelligent tools and automatic image generation which is available at our fingertips these days, it is hard to communicate how to how to exactly make our images look the way we want them to look. So one of the most famous, if not the famous software in the world for image editing and basically all things image is Photoshop. And I think in 2022 or 2023, um, they came up with this solution called generative fill, which works like, I'll just let the GIF play. You select a target object or objects, or you select a region, and you describe the replacement you want in that region, and it creates it for you. Now, Photoshop being a paid product and coming from Adobe, it is not available for us to dissect and really understand what is going on under the hood. So, and like us being machine learning engineers or even just curious people, we want to understand how this plays out, or how this actually works. We know a little bit about how it works. It probably works with an image generation model, but it feels so perfect at times that we want to understand how they do it. And there's not a lot of open research from Adobe, so we thought about open sourcing this technology and this tool, and open sourcing generative fill. So again, to put things into context, what we want to do is we want to you know uh, take in an image, give a prompt, select a region or not select a region, and based on that prompt, that region will be changed to something that we want to see or something that we want to edit. uh, what we actually thought while doing this project is that if you look at this if you look at this GIF, basically what you're doing is you are selecting a region, or you're painting over that region, or creating a mask of that region, or creating a selection, and you're telling the prompt or telling the machine what you want to see. And we thought of this as a crutch. We thought of this as something that might be undesirable to the end user. So for a user, uh, it might be really great if they could just upload an image to the software and describe what changes they want to do in that image and have that be done. And that is like the end goal of what we were visualizing. And we also wanted to be very specific that only the part of the region or part of the image that they want to edit should be edited, and the rest of the image should basically remain as it is. So with that in mind, we started this project called Open Sourcing Generative Fill. And since like this was a really fun kind of 2 day 1 week kind of a sprint, where we sort of tried a lot of models, tried a lot of tools, and put them together to see how these tools interact with each other and how it plays out when we sort of join the pieces together and have it work end to end. So we something to point out at this stage is that all of the models and all of the technologies that we have used in this project is inference only. There's no training, even not fine tuning happening. And we'll go into details at the end about training and fine tuning, and what parts can be fine tuned and what parts can be swapped with a trainable module. But for now, as the project exists, it is it is an assembly of components which are inference only. So whatever like so we whatever you see on the screen is kind of like the timeline of how we tried to solve things with this project. So remember when I talked about editing an image and selecting a region. So if you select a region, you kind of need a way to segment that, um, and sort of demarcate it and have it be differentiated from the rest of the image. We can solve this. It turns out we can solve this with the use of segmentation. And one of the best, if not the best model out there is the segment anything model from Meta, which I think came out last year. And what we try to do is if we gave a region and if we prompted the model with that region of an image, it was basically able to return a segmented object to us. Now, next, what we realized is that it's not enough. We kind of need, we just don't need a region, or we don't want the users to go in and prompt with a region. We want the users to say, like, okay, I want to replace the owl, or I want to replace the face, and that face should be detected from the text and segmented out inside the image. And that was possible with an additional model, which is basically able to solve object detection. And it turned out that owl v2, which is a vision transformer, is capable of doing that. So we joined like owl v2 plus the segment anything model, and we had this really cool pipeline where you could give a text like an owl or a dog or a bottle, and it would be able to segment that object in the image if it was present. So with that, like we had kind of a way to identify objects and segment them automatically. Next, what we did is replacing that object. So as we saw in the GIF, with Photoshop, you kind of need to replace or edit the part of the image. And the way this is possible is something called image in painting. So image in painting, as it originally existed, it was able to fix coloration issues, or de-oldify old photographs and make them look modern based on certain masks or certain regions which are segmented in the image. And what we thought, like, with diffusers, what is possible now is that you can segment out or you can mask out a certain part of the image, and that part can be transformed into anything that you provide in the edit prompt. So we basically joined these three models, which is owl v2, segment anything model, and image inbending with stable diffusion XL. And we had this pipeline where if you said dog and then said cat, an image with a dog will be replaced with a cat. uh, and we wanted to do more than that. Remember where we said, like, basically prompting a part of the image or selecting a region was kind of a crutch. It is not desirable, and the end user or someone who is absolutely not familiar with image editing or Photoshop or high-end tools, they might just want to upload an image, describe what they want to do or change in the image, and have it be done. So for that, we needed a way to extract the text, like replace dog with a cat. So you need to extract dog and cat from your prompt. And we did, like, we first thought that this is possible using a really simple NAR model, which is named entity recognition. But we later figured out that prompts come in all shapes and sizes, and named entity recognition does not solve this at scale. So we used a language model, and a language model with few examples of prompting, we were able to solve that. And we also needed an image captioning model, because we have to describe the original image for the prompt that would go into the uh, uh, diffusers library or the SDXL model. And I understand at this point you're really tired of seeing me wave my hands and uh, make you look at a string of models on the screen. So I'll make this more interactive. I'll make switch over to a place with the diagram. And what is happening here is basically what the entire workflow is. So we have an image, and when the image first comes in, the image goes to an image captioning model. And you can see that if you really squint at your screen, you'll be able to see that it's a small dog running through a field of grass. So the image captioning model we have used is a blip model, and it's kind of good. It doesn't get stuffed around, so it gave a usable kind of caption. And that caption uh, goes to the language model. And the language model we have used here is a Qwen 1.5 billion chat model. And along with that caption goes the original prompt. Remember, this is the part which comes from the user. So the user is basically giving an image and this prompt, which is the input prompt. So this goes from the user into the language model, and the language model kind of throws out a dog, which is a particular object that the segmentation model has to segment, and a caption where dog has been replaced with tiger. So it's a small tiger running through a field of grass, and this dog object or this entity is being fed back into the owl fit or the vision transformer, which is responsible for object detection. And you can see, like, of course, this will all be open sourced and you'll be able to check this later. But you can see that the dog has been, correctly identified, and there's a bounding box here around the dog. So dog goes into the owl fit model, and the owl VIT kind of recognizes the dog and passes that region or that bounding box where the dog is present to the SAM or segment anything model. And what segment anything does is that it does the segmentation perfectly and returns a mask uh, to the diffusion model. And the way diffusion in painting works is that you need the original image, you need a mask, and you need a prompt or a text that describes what you want to change in that mask region. So we have the mask, that's one problem solved. We have the original image, which comes from here. And we also have the text, which says a small tiger running through a field of grass, which is the part that we want to change in the image. And it goes into the SDXL in painting model and produces this, which is the output uh, like that you get from this entire end-to-end workflow. And the noticeable thing at this point is to remember that the user only gives this part and this part to the project, like to the application, and the application is able to return this. And this is this is a sizable way. It's a sizable leap forward, because you're not specifying a particular region inside the image and saying, okay, just work here, because that is easy and that is also hard for the user to do. That is easy for the models to solve, but that is hard for the user to do if the user is technologically challenged, or they are not familiar with these tools. So you pass in an image, you pass in a prompt, and it does the editing for you. That was our vision. And like, this is our kind of gallery of models that we sort of pieced together, assembled our team, and tried to solve it. So with that, like, of course, this is we have done this from the very first moment as an open source project. So if you scan this, if you are watching on your phones or on your tablets, you can scan this, and I think it has already been put into the comments. You can go to the repository, and as Aritra is demoing the model and demoing all the workflow, you can, if you want to, do it alongside him, or you can do it afterwards, or do it at all. But we would prefer if you do it, and if you encounter any errors, because you would, I encourage you, or we encourage you, to let us know in the chat, because we will sort of after all of this is done, after the demo is done, we'll talk about what are the challenges now and what kind of errors you might be facing. So I've blabbered enough with my hand wavy gestures, and over to you, Aritra.
Right. So thanks, Ritwik, for the lovely, slides. And he talks about, like, Ritwik is the person who talks a lot about theory. And I always like talking about code first because that is the way I generally learn things. So to keep the context very clear, what we do is we have an image as an input, and we have an edit prompt as the text input that goes into the entire pipeline. We do not call the pipeline a model because it's a gallery of models, as Ritik talked about in his diagram. So we will say it as a pipeline of a lot of models working together. So we give an image, we give an edit prompt, and what we want as an output is just one single image that has been modified. Like, the input image has been modified into the output image based on or conditioned on the edit prompt. So what I'm trying to show is a pip installable package called Open Generative Fill. This is also the repository. So if you go to github.com/Ritwik Raha /Open Generative Fill, that is share this tab instead, that is this Open Generative Fill. This is essentially the repository that houses all of the pipelines, all of the code that we have used till date to explain the entire process. So going back to my demo, we can pip install it using the git plus method because it's a GitHub repository. It's not yet published in PyPy, so sorry for that. And then what we do is we import a bunch of modules. That the first module is Torch, because we have used all the models from Hugging Face Transformers, and they are Torch first, hence Torch. Also Matplotlib, because we would like to visualize the inputs, we would like to visualize the outputs, and also the segmentation masks and whatnot. And the entire packages that we have created inside of our package called Open Generative Fill are these. So we have a config file, and I'm going to show each and every one of these little modules that we have created in the GitHub repository a little while later. First, I just want to run the entire collab notebook with okay, don't complain, collab. I'm going to use you right now. So we are going to explain the entire pipeline first. We'll see the output, we'll see the inputs as well. And then we are going to go into the GitHub repo and navigate our ways into what goes where, so that people who are interested, people who have joined now, people who are going to view this YouTube stream later, they can go into the repository, understand what goes where, and maybe create new issues, create new PRs, help us in the entire movement of open sourcing a generative fill pipeline. So we have a config, we have a run LM model, which is language model. We can also use the load image because essentially the input is an image. We have vision models as well. So we are using caption, inpainting, and segmentation pipeline models. So that's about it from the entire Python package point of view. And here, as you can see, that we have an image URL, and the load image function takes in the image URL and it loads the entire image. So this is the image URL. The edit prompt is change the bottle to a wine. We also have a seed value for reproducibility. So the seed value goes into a torch generator, that is a PRNG generator, and that generator is used in the inpainting pipeline. So to cut things short, we have an image URL, we have that edit prompt, and you can select a seed value just for reproducibility. So that's about it. We set up the configuration. So we set device to CUDA if Torch, like the Torch CUDA API gets hold of a GPU, or else it can run on CPU. So before going into this, as I am already talking about device, you can see that my collab instance is running on a T4. So this is the most baseline GPU that you can get on your Google Colab, and I think free Google Colab users, as in not pro Colab users, also have access to T4s. So anybody anywhere in the world with a web browser access to Google Colab can actually run this entire code and get their inferences in maybe a minute or so. So that's kind of cool. So we initialize the device. We also get the generator up, and then we load the image. So let me hit run on this cell. That's because I did not do this. Uh, Errors and demos, they go hand in hand. So right after that happens, I'm going to plot the image, that is the input image. So that's the image that we have. So it's a bottle which is on a bed, and that's the image that we have. And the edit prompt was change the bottle to a wine. So first, what we do is we take in the image and we try to caption the image or generate a caption that best describes this image. Why do we do it? We're going to talk about why we need captions and where these captions are required a little later. But the first things first, we have an image, we are going to generate a caption. And if we generate the caption, and it's going to take some time because it loads the entire model from Hugging Face Hub. It also has a bunch of, see, PyTorch model.bin, config.json, everything kind of gets loaded. And then you will eventually have an output cell which talks about the description. So using caption model, we are using the Salesforce Blip image caption base. And most of the models that we have used are base or small because we want to fit the entire thing into a T4 GPU for the sake of accessibility. And then we have a caption generated by this model called a bottle of beer sitting on a bed, which is a single line caption for this image, which is not bad. We are not using a big enough model like Lava or Fuyu, which can do a lot better with captions, because we want to, again, fit the entire thing into T4 without any quantization, without any, how do you call it, distillation and stuff like that. We just want to use the model that we have in Hub, use it, and put it all on a T4 and get the outputs. So that was our main motivation. So a bottle of beer sitting on a bed. That's good. Now we go to the language side of things. So remember what our edit prompt was. The edit prompt is change the bottle to a wine. And we use the language model to do two things. One is once you provide it the caption and the edit prompt, so the language model ingests two inputs. One is the caption from the captioning model, and the other is the edit prompt from the user. So the language model kind of does two things. One is it tells me what is it that we need to replace from the edit prompt, and the replaced caption, as in the caption that we got, we need to replace the caption as we go based on the edit prompt. So to make things clear, I'll go here. We use the Quen 1.5, which is a zero point 0.5 billion chat model. The object to replace is the bottle. So let's go to the edit prompt. The edit prompt says change the bottle to a wine. That means we want the bottle inside of the image to be replaced by a wine bottle, right? So the model tells me that the object which needs to be replaced is a bottle, and the caption for InPaint is a wine glass sitting on a bed, elegant and sophisticated, with a glass of red wine on top, a touch of elegance, and blah, blah, blah. So if you are already into image in painting or diffusion models, text to image models, you already kind of get the hang of where I'm going with this language model's outputs. But if you're not, don't worry. What we are trying to do is we are trying to first, from the edit prompt, get which object I have to, kind of mask out from the input image. So as the language model says, the bottle is the object that we need to mask out. That is, if this is the bottle, we need to mask this out. And what do we mask it out with? We mask it out with a wine glass sitting on a bed, elegant and sophisticated, and so on. So this is the in painting prompt, right? So let's again rewind. And I like doing this way of education because it kind of drills down the pointers that we are trying to assert to you. One is we have an input image, we have an edit prompt. The input image gets into a captioning model, and you have a caption of the image. And then you take a language model and put the caption as well as the edit prompt. So you provide both the edit prompt as well as the caption. And now you have two outputs of the language model. One is the bottle, that is the object to replace. And the other part is the caption to inpaint. That is the prompt to inpaint. I'm sorry, it should be prompt for inpainting, not caption. But yeah, you get the hang of it. So after that, we move into my favorite part of the entire pipeline is how would you, if you have an image of a bottle on a bed, how would you ask a vision model to create a segmentation mask based on just text? It's not points, it's not bounding boxes, it's just text that we provide. And the model will be able to locate the bottle and draw a segmentation mask on top of it. Turns out that segmentation anything model, that is SAM from Meta, already does it in the papers, but Meta did not ever release the text encoder. So we had to hack a way around it. So what we did is we used two models instead of one segmentation model. The first one is a detection model, and the second one is the segmentation anything model. What does the detection model do? Now, the detection model that is being used here is called OWL v2. So what OWL v2 takes is a text and an image, and it draws a bounding box on top of the object that you want it to detect. Now, once you have the bounding box, if you provide that bounding box to segment anything can give you the segmentation mask quite well. And by quite well, if I, you can already see it. So it really gives you a brilliant kind of mask of the bottle in the entire input image by just saying what I want. So I want bottle. I'm providing to replace to the entire pipeline of segmentation and detection, and it gives me the segmentation mask for the bottle, and it's pretty nice. So out of vocabulary object detection done, out of vocabulary segmentation done, kind of, because that's the part where we kind of faltered in the entire pipeline. Sam is very dependent on owl v2. That should not be the case. It should be one segmentation model which takes in object, which takes in the which takes in the text, which takes in the input image, and it gives you the mask. But right now what our pipeline has, it is broken into two chunks. One is the object detection, which is out of vocabulary object detection, and the other part is SAM, in which the object detection provides the bounding box, and the bounding box then gives you the segmentation mask. So sometimes there are out of vocabulary words for the bounding box generator itself, and that kind of makes the entire pipeline go crazy. So if you think you can help us with it, go to the repository immediately, bring the issue into our notice, just write an issue and tag us. We'll be able to take that up, and we can have a brilliant collaborative effort for this. So just putting out the word that this is where it falters and we need help on this. So just to continue with the entire pipeline, now we have the input image, we have the edit prompt, we did a bunch of processing, and we have the segmentation mask. What else? Now comes the inpainting pipeline, and we provide all of the entire things that we have processed till date. So we provided the input image, we provided the segmentation mask, we also provide the replaced caption. Remember, the language model gave us two outputs. One is what you want to replace, and the other is the replaced caption, as in the entire prompt which needs to be replaced. And you give it the generator, you give it the device, and blah blah blah. Not going to blabber too much about it, and I'm going to be really careful to not showcase the already printed or already shown figure. I'm going to just click on play so that we can get something very new in this collab notebook. And while we are at it, and it takes a couple of seconds, so I just wanted to rephrase the entire pipeline again. So one, we have an input image. Two, we have the edit prompt, and that's all we need for the entire pipeline to work. Some things that we need help on is, one, we don't think a language model can be the best way to go around, like a large language model, which is a chat based kind of model, is the best way to go around having objects and the entire caption written. If that's the best way to go around it, I might be like, I am sorry to be so naive. I am not very well versed with language, but if you think that's not the case, if you think that's the case, again, go to our repository, uh, click up the issues tab, create an issue, and we'll be looking into your issues today or maybe tomorrow or any day. So 25% done, that's good. And after the LLMs, we have the captioning model, we have the segmentation model, we have the object detection model, which takes in the image, which takes in the out of vocabulary words, and then it creates the entire pipeline of segmentation and detection. So that's done, and that's not bad. So what we started off with is this, and we have carefully replaced that entire image with a bottle of wine, which looks good. I must admit that it looks good. It's not the most exquisite, or it's something which you can do on your own. It must be better. But with the entire thing automated, you kind of appreciate how easy it is to run the entire collab notebook, just feed in an image, get the edit prompts, and it just works. So I'm going to go into the GitHub repository like 2 minutes later. What I want you all to focus on today is that go into the GitHub repo. This collab notebook is situated in the notebooks folder of the repository. And once you go into this collab notebook, take a copy of this collab notebook, run your experiments. It's pip installable. The entire repository is pip installable, so it won't be a problem for you to install it on your collab notebook or maybe even your local computer, and try it with various images, see where it fails, and also bring into notice that, hey, this is the image that we have tried, this is the edit prompt that we have tried, and I think the segmentation mask is not built right. I think the language model is not being able to figure out what to replace and what is the inpainted caption. That will be really helpful for me and Ritwik to get the entire ball rolling. And that's something which we want earnestly. So going into the share this tab. So going into the repo, and how can you navigate the repo? You don't have to take much concern about dev containers. You don't have to take much concern about PyProject, poetry, and all that stuff. That's something which I did to make this entire repository pip installable. The only thing that you need to work on are two folders. One is notebooks, in which if you go, you will see a bunch of notebooks that me and Ritwik have created. And Open Generative Fill, that is the package that we are kind of pip installing and also using. So let's go into Open Generative Fill. These are the only modules that we need. So let's go one by one into all the code and understand. And I am sure people who are watching it or maybe watch later say that, hey, this is really easy. It does not have like the entire architecture is written. It does not let you have all the uh, the code for training the models. Nothing of that sort. It's just inference only, and that is how we wanted people to access these models really quickly. So config.py, we use image size of 512 and 512 to make the computations easy for on a T4 instance. The language model is Qwen, the caption model is Salesforce, the detection model is Owl V2, segmentation is SAM, and inpainting is Stable Diffusion XL. And this is also something which is very interesting. If you go to Hugging Face Hub and you have your own language model ID handy, you can just put that model ID into the config.py and run the collab notebook, and it's going to run off the bat due to the fact that it's inference only, and Hugging Face has a brilliant API designed for inferences. It's going to run off the bat, and you will see a lot of changes once you run those different models using the config.py. So that's something which is very cool. Then load data.py is very simple. It's just the PIL operation for image.open. You do an image.resize because we wanted to resize it to a fixed 512 cross 512 dimension, spatial dimension. So that's basically it. If you want to add in your assertions to make the loading pipeline more robust, please feel free to do it. Then we move into the the caption model, because that's where we went step by step. So the caption model is just these two lines. So we take the model ID from config, we do a from pre-trained, so the blip kind of gets installed. We have the inputs for caption ID with no grads. We don't want, because it's inference only, we don't want gradients to take up a bunch of the GPU space. With no grads, we generate the caption and we return the caption. That's about it. Then we go to the LM model, and we did a neat little trick, and that's thanks to Pedro, who is also in the TFUG Sao Paulo team. Thanks to him and for his issue, where he mentions that having an LM a large language model, prompt what we want, as in we first in the first iterations of the project, we were not doing what we were supposed to with the LM model, and it was giving a lot of errors. So what he did is he told us that the LM model can give you the captions pretty neat, so you don't have to use string manipulations. You can just use the LM model and create the captions, and it's going to work. And it did. It eventually did. So thanks, Pedro, for the help. And what we do here is called few shot prompting. So we have a few few examples that we want the language model to see, and then we move into the actual generation of the language model, and we return the to replace and the replaced caption. So to replace is the bottle, and the replaced caption is the red wine aesthetics with blah blah blah. So you get the hang of it. So the LM models is just that. So create a bunch of role and create a bunch of content that you want the language model to see. So that those are your prompts. And few short prompting is because you give an example of few of the prompts that you want the language model to see before it generates something. So that's good. And then we again move into vision models, and we did the caption model. The segmentation pipeline consists of two models, as we said. One is OWL v2, that is the object detection pipeline, and that gives you boxes. And then we have the SAM model, which takes the boxes as input boxes and provides you with the segmentation mask. So that's basically it. And then after we have the segmentation model, we have the language model giving you a replaced caption and whatnot. We straight away run the inpending pipeline, in which we use this we use SDXL, I think. Yeah, SDXL. And then we use the prompt as the replaced caption, and we print out or we return the output. So that's basically whatever we have covered in, say, 1, 2, 3, 4, 5, 6 of these files. And feel free to look into them, use the code, maybe fork the repo, give us PRs stating that how we completely missed something, or how we can add something else onto this entire workspace. And we would eventually love collaborations. And another little thing that I wanted to mention before I sign off from the entire slides and give it back to Ritwik is this issue. So we have an issue called a way forward, wherein we kind of collaborate with a bunch of people all over the world who want to see this repository grow. So I had a bunch of, so it's commented last week. So I had a bunch of ideas, and what did not work out were also filled in. Shaq Paul, who is also core maintainer of the Hugging Face diffusers library, asked us to try instruct pix to pix and MGIE. Then came in Pedro, who helped us with a bunch of other things, and it gave us insanely good results. Ritwik again talked about how things work, how things don't work, and stuff like that. So, what I really want you all to understand about this is that if you are willing to contribute, or even if you just have an idea to propose to us, please feel free to go into this issue, which is the issue number 2. Feel free to go into this, write out your heart's content, and please make it really aligned to what we are trying to do. We are trying to not only open source the generative fill part, we are also trying to have some fun. So if you have a fun idea which we could do within our scope, feel free to write about it, or maybe also create a PR, and um, we'll be more than happy to take those up. So yeah, that's what we have been up to. Ritik, if you have some parting notes.
Yeah.
Cool.
So
So go ahead, Ritwik. I think you have some questions in the comments, so you may want to respond this.
Cool.
sure. Let's first go to the questions because they might be more interesting.
Yeah, there is one question. Ritwik already like answered it in the comments, but I think it's like good to ask again here. That is, if you're planning to apply this on video data as well. I know that
Yeah.
video is like a different domain, but yeah.
Yeah, I'll take that. Firstly, what I'll do is I'll try to list out the challenges where we want to, or how we can kind of see applying this to video data. So what happens when you want to sort of apply image processing pipelines to video data is that you take a video, file, and then you sort of take a stream reader and dissect the video file into frames, because a video is a collection of frames, and then you apply the image processing pipeline to each of those frames till you reach the end of that frame. Now the one challenge where what we see with this, or two challenges, is that there are two kinds of models. One is the owl VIT plus SAM kind of model, which does the recognition and segmentation part, and then there's the SDXL model, so which does the inpainting. So the SDXL model is kind of slow, like it would need time to process and inpaint the objects, and having that kind of like pause between frames, where in each frame you're kind of inpainting that object, and that object is moving, is going to be a little bit of challenge. So we have to kind of squeeze down the model on the size part of things, but not on its ability to generate good wine bottles, because wine bottles are important. But we also need, circling back to the first problem, is that we also need a very efficient pipeline for recognition and then segmentation. So we kind of have SAM, and there are variants of SAM which are little bit smaller and they load better, I guess. But with object detection, you can't use a VIT. I don't know if you saw this or not. There came out models called YOLO World last week, and also YOLO V9, which came out last 2 days back. So those are really great on video data and recognizing objects in video data. So yeah, I'll probably spend the weekend doing that. Yeah, but yes. So thanks for the question. It's a really interesting question, and really interesting problem.
Yeah.
So
If I can contribute on this, I think one of like another challenge on this type of stuff using video is that like when you're doing inference using any kind of diffusion model, like every inference is different. So for a lot of different frames, you may have different objects, like with small details different, but it's
mhm.
kind of difficult to keep the consistency. So I guess this is another challenge. I don't know if it's
Yes.
like solved, but yeah, it's a big challenge.
It is, and it's the way you said, like exactly right. Because if you look at the SDXL printing pipeline, what it does is that it selects a masked area and kind of replaces it based on basically denoising a noisy image. think of it where the masked area is moving for every picture across the other objects, and that is that is in that context it is difficult to maintain consistency. So yeah.
Yeah, so the other question was like about the image generation model you were using. Ritwik like answered that you are using Stable Diffusion Excel in Paint, but I have a question on this. And like a lot of people are doing fine tuning on top of like Stable Diffusion Excel, and other models, but like they are all doing this for image like text to image models. And when it goes like to in Paint models, we are talking not only about text to image, but we also need to give it input like the initial image and the mask. And it's kind of difficult to find like in painting models, like fine tuned in painting models. And it's not like that easy to fine tune in painting models as it is to fine tune in text to image models. So one of the things I was looking is that you have a trick to doing paint like without need to train anything. It's just because of the VAE. But I don't know. Do you guys have any thoughts on this? Like, how can we try to uh, I know that people are merging models, but I don't know if it's the best option, or how can we overcome this challenge of like we don't have so many in painting models.
I can sort of try to answer that.
Yeah,
So
sure.
the way the way in painting models are done is that you basically take the same concept of training a unit model with diffusion, where you denoise a noisy image, and then you sort of also condition it on the text prompt, and also on a part of the image or a mask of the image. So in that context, like, I think what we really need to see is that there have been a lot of developments for depth to image or canny to image, and sort of those kind of models where you supply the model or the diffusion model with a separate image vector or a separate source, and then have that source sort of guide the denoising process. What we need to look at is applying those same sort of concepts uh, of of, of you know giving in another input to to the to the source diffusion model, and have it do the denoising part. And I also talked to Shai Paul, as we mentioned him in the repository extensively during this project, and I was at some point really frustrated with like all the parameters, and how do I get image indenting to work deterministically. And some of the ideas that I got to understand is that it always depends upon your how much of, not just how well your text prompt is, but how much the image size is. So for example, this might be interesting to some folks. We tried this on 512 and cross 512, and I think Aritra scolded me for 3 days, saying the images are not great. And we sort of I sort of came back on the first day apologizing to him that, hey man, I missed that SDXL works on 1024 cross 1024. It's written in the documentation. So 512 cross 512 isn't really that great. And something really interesting happens if you upscale the resolution as well. So if you use 2048 cross 2048, you'll see a lot of weird artifacts or duplication errors. And the 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 thing that we need to come in terms with is that this is a stochastic process, and we are guiding it, and we won't have complete control always. But to come back and answer your original question, I think model merging is great, and I've looked into it, and it does give you cool looking images. But we need to think about like sort of adapting original diffusion models with extra inputs, like canny images, canny edge detected images, or depth images. And instead of using those, we should use the mask and sort of prompt it that way.
Cool. Yeah, I think there is one last comment from Jeff. There is two recent models on image generation space in terms of performance versus quality are Stable Cascade and Stable Diffusion XL Lightning. I believe they could add value to your pipeline in the future too. Yeah, I guess, but the thing is, like with Stable Cascade, we don't have the in-painting option right now, right?
Yes.
And I don't think it'd
Yes.
be easy to achieve this because it has like the last model is like a small model that is basically like attention layers and some feed forward layers. So you don't have a way to do this translation of the pixel space like okay, just interpolate the mask and keep the noise here. So this is the
Yes.
hard part about the inpaint, and yeah, I suffer this a lot on my job. So this is why I'm asking because the inpaint is quite difficult to handle. But
Yes.
yeah, like I
And
guess. Go ahead. Go ahead.
they sort of, for Stable Cascade, they sort of laid this out in their repository, saying that we'll come out with face models and in painting models and out painting models. But yeah, looking at their code, it's kind of like not there for in painting yet. And I think it's in diffusers as well, like just text to image generation. But as you said, in painting is hard. And what is really more harder is where you give a prompt and you have the rest of the image stay the same. I mean, you can use VA image processors and stuff like that, but it's just a mask that is overlaid. But
Yeah.
it's letting the rest of the image stay the same is kind of yeah. I mean, it's still undergoing research, isn't it?
Yeah. No, but like overall, I think the project's like amazing. I'm looking forward to try more things. One of the things that I want to do, there is like there is a repo called Stable Fast. It's basically like a
Yes.
compilation tool for like diffusion models on top of diffusers. So I want to try to compile some of the models and see like how faster the pipeline can go. So, but
Yes.
like I think open sourcing this is really amazing because a lot of people yeah, like just look at these tools like in softwares like Photoshop and other stuff, but they don't know how it works like under the hood. So it's super nice, and the code is so clean that like I spent like I don't know 15 minutes reading the code, and I was okay. I know what's happening. So because like sometimes we spend a lot of time doing like on the code base to understand what is happening, and the code's so clean. So yeah, thank you guys for open sourcing this. I think like it would be a great contribution for people that like want to know more about diffusion, segmentation, and how to make like because this is applied machine learning because you are getting a bunch of stuff that like they don't talk with each other and then you are making everything together work in a
Talk.
real world application. Yeah. So it's super good. I don't know if you have a last message or if people have any more questions. So feel free.
And I just wanted to add in one little thing because I was kind of feeling uh, that the entire project revolves around inpainting a lot, that people kind of are guided into inpainting and diffusion mode than the other side of it, wherein the segmentation is really important. If you don't get the segmentation right, you're not going to get into the inpainting. And also, my heart broke when I got into the SAM repository from Meta and did not find the text encoder. And that is why that is when I went into my Twitter handle and asked Meta to please open source their text encoder. But jokes aside, what I would really like is also a project, like a side project, wherein I could get into uh, probing the segmentation masks with maybe a pre-trained text encoder, so that I don't need a detection model at all. I just can get two pre-trained models which don't talk to each other, like you said, Pedro, and make them talk, wherein I can give in a text and it encodes the text into a vector, and that vector kind of hits the sweet spot of SAM, wherein it gives the segmentation model. But that's something which needs to be talked about, and how the API design is going to be And if in the meantime Meta thinks that now is the time we can get you the text encoder, that kind of makes my project fail. But again, it's a fun project to think about. If you get the inpainting, like if you get the segmentation model right, you can basically go into inpainting a lot better. So
I
that's
know that one thing that people is doing is that like they are using, because if I'm not wrong, segment anything has like an auto mask that masks everything like that.
right.
It finds that it is important. So what people are doing is basically like they are getting all the segmentations and they assign one by one to a clip model and comparing, like if like for example you want a dog, they compare, they pass the dog prompt to the text encoder and the segmentation mask they
Hmm.
got from the segmented thing, and see like the cosine similarity between them and get the one
Right.
that has the highest value. Like this kind of works, but one of the things is that
Exactly.
you are like, if you don't have a mod, if you don't have a dog there, you will return like something that has the highest cosine similarity. So it kind of works, but not works. You have a lot of like things to handle, like what's the threshold, uh, overlap between masks, because you can have like the tongue of the dog, the eyes of the dog itself. So it's kind of difficult to get all of
Right.
this. But yeah, no, I am with you, because when the first time I saw segment anything, I was using the demo from the Meta website, and they said that you can like prompt by click, by points, by bounding box, or by text, and I was, oh
Yes.
my god, text, man, it's amazing. And then no, I didn't find.
Exactly what I went through. So yeah, if anybody from Facebook or Meta is looking at this stream,
Please.
we three eventually, yeah, please give the text encoders. Yeah, that's fun.
So cool, guys. Hitchik, do you have anything to say?
Yeah, I just wanted to add, like, sorry for taking so long, guys, but yeah, as
No.
Arthur said, the stable diffusion part kind of steals the show. But yes, the object detection is like really at the center of it. And also at the center of it is the language model, which we kind of were rubbing our eyes as well, because getting a language model to give you structured output, like, is really a pain. And you can't sort of do that with few shot prompting. We tried fine tuning as well, the model, and it didn't work, of course, because we didn't have thousands and thousands of data points. So yeah, like, language is still not solved. And with even with open source small models, it's really a challenge. So if you're looking at the repository now or whenever, we encourage you to look at those bits as well, because they are super important. And I don't have anything else.
Cool. So, guys, thank you a lot. Like, I think it was an incredible talk. I think everyone that was watching definitely learned something new. The project is amazing. I'm looking forward to keep contributing. So, yeah, as soon as I have time, I will try this stuff and I'll let you know.
Sure.
And feel free to return here. Like, you are welcome. So, yeah, that's
Thank you
it.
Absolutely.
so much.
Thank you, Pedro. We had a wonderful time. See you.
Bye bye. See you.
See you. Bye bye.